You've seen it everywhere for the past couple of years, right? All these AI hacks and magic words promising to unlock some hidden power. But if you've actually tried them, you know they're pretty fragile. I'm here to tell you that phase is officially over. We're moving beyond cheap tricks and into the era of professional AI orchestration. And that is exactly what this masterclass is all about. So let's just get right to it and talk about why this happens. You see that viral post with the so-called God mode prompt. You get excited, you try it, and it either falls flat or it just stops working a week later. You know why? It's because those tricks are built on shifting sand. They just don't give you the consistent, reliable results you need to do any kind of serious work. Because here's the thing, professional results don't come from tricks, they come from technique. They come from thinking like an engineer when you communicate with AI. So in this explainer, we're not just going to share a few tips. No, we are building a complete A to Z curriculum for mastering this incredibly powerful interface. So here's the game plan. We've got 5 essential parts. We're going to start with the absolute basics, how the language interface actually works. Then, we'll build on that with blueprints for getting logical, coherent results. After that, we'll get into the different dialects of modern AI platforms, tackle the super important issues of reliability and security, and finally, we'll look ahead to the future of automated AI orchestration. By the end, you'll have a rock-solid framework. Okay, let's dive in. All right, part 1, the language interface. Look, before you can give good instructions, you have to understand the machine you're talking to. This is the step most people skip, and honestly, it's why they struggle. We need to get a handle on how these models actually think. So here is the most crucial concept to grasp. AI models do not understand words or ideas like we do. They see the world through something called tokens. Tokenization is just the process of breaking our text down into these little numerical chunks. The AI is basically a probability engine. Think of it like a hyper-advanced version of your phone's autocomplete, just predicting the most likely next number or token in a sequence. And this is literally how the model sees it. The phrase prompt engineering is systematic isn't a single idea to the AI. It becomes this sequence of tokens. You see prompt, then a space token, then engineering. And look, it even breaks up systematic into system and attic. This is why your exact wording is so critical. You're not just talking, you are directly influencing a mathematical process. With that in mind, a professional prompt is not just a question. It's a structured document. It has a clear anatomy. First, you give it a role. Act as a senior legal analyst. Then, the specific task. Summarize this case file. You have to provide the context, the file itself. Then you add constraints. Keep it under 200 words and don't use any legal jargon. You can even give it examples of the style you're looking for. And finally, you tell it the exact output format you want, like a bulleted list. Okay, let's move to part 2 and see how this all builds up. Now that we've got the basic structure down, we can start using professional blueprints to build really powerful prompts. These are frameworks designed to guide the AI's reasoning so it doesn't have to guess what we want. A real industry standard for this is a framework called CO star. It's basically a simple checklist to make sure you've covered all your bases. You've got context, objective, style, tone, audience, and the response format. This little framework is brilliant because it forces you to go from just a vague idea in your head to a super precise set of instructions, covering every angle the AI might need. Now, even with a great framework, AIs can still mess up, especially with math or complex logic. And this is where one of the most powerful techniques in all of prompt engineering comes into play: chain of thought reasoning. On the left, you see a model that just jumps to the wrong answer. But on the right, well, something changes. All you do is add one simple phrase. Let's think step by step. That's it. It's almost ridiculously simple. But what it does is it forces the model to write out its reasoning process, to show its work before it gives you the final answer. The improvement you get on logical tasks is just astounding. It's the difference between trying to do complex math in your head versus writing it all down on paper. And we can take that concept even further. Tree of thoughts is an advanced technique that really builds on that idea. You're basically asking the AI to create a small team of experts inside its own digital mind. You have it explore multiple different ways to solve a problem, then have those different paths critique each other's logic, and then, finally, converge on the best possible solution. It's like running a whole boardroom debate inside the model to solve one single complex problem. Okay, part 3, platforms and modalities. Now, this is crucial, and it trips a lot of people up. Not all AI models are the same. They have different architectures, they were trained differently, and that means you need to learn to speak their specific dialects to really get the best results. And this really breaks down the key differences for the big players. With OpenAI's models like GPT-4o, you want to put your core, unchangeable rules in that system or developer role. For Anthropic's Claude, it responds incredibly well when you use XML tags like context and instructions to neatly separate the different parts of your prompt. And then with Google's Gemini, which can handle massive amounts of data, the best practice is to load all your data in first and then put your instructions at the very end. But the evolution doesn't stop with different models. We are moving so fast beyond just text. The real state-of-the-art in prompting now involves creating what we call input clusters, where a single request might combine a text instruction, a few images, and maybe even a video file, all at once. So the key in this new multimodal world is specificity. A lazy, vague prompt like, "What's in this video?" is going to get you a generic, basically useless summary. A professional prompt is precise. It says, "Analyze this factory security footage, flag any instance where a worker is not wearing a helmet, and provide the specific timestamp." The difference in the quality of the output is just night and day. All right, let's move on to one of the absolute most important topics for any professional using AI: reliability and security. Because let's face it, if you can't trust the output, the entire system is useless. So we have to design our prompts to deal with risks like hallucinations and to defend against people trying to attack the system. And if you're wondering why this is so critical, this number says it all. Alphabet, Google's parent company, lost $100 billion in market value after a single AI demo produced one factual error, a hallucination. In a professional setting, the financial, legal, and reputational risks are just enormous. So how do we fight this? Well, the single most effective technique we have is called Retrieval Augmented Generation, or RAG. It's a game changer. Instead of letting the model just pull answers from its massive, messy internal training data, you ground it. You give it a specific set of documents, your company's internal wiki, a legal contract, whatever, and you instruct the AI to only use that information to answer the question. This creates a single source of truth and just drastically cuts down the risk of it making stuff up. This is probably the most important technique for building enterprise-grade, trustworthy AI today. And beyond just preventing mistakes, we also have to actively defend against users who are trying to break the system on purpose. These are called adversarial attacks. Prompt injection, for example, is where a user hides a malicious instruction inside a piece of text you're asking the AI to summarize. This tricks it into ignoring your rules and following theirs. Then you've got things like prompt leaking to steer your instructions and jailbreaking to bypass safety filters. Designing defensive prompts is now a core skill for any serious orchestrator. And this brings us to our final section, the future of orchestration. Because the job of a prompt engineer is changing as fast as the models themselves, we are quickly moving away from just manually writing individual prompts and toward designing and managing entire automated systems. I mean, this timeline just shows you the incredible speed of this evolution. Just a few years ago, back in 2020, just giving a few examples in a prompt was considered revolutionary. By 2022, chain of thought was the new standard for any complex reasoning. And now, we are entering the era of programmatic optimization, where the prompts themselves are becoming automated. And this really represents a fundamental shift in how we think about this. On the left, you've got traditional prompting, which, let's be honest, involves a lot of manual guesswork and trial and error. But on the right, you have new frameworks like DSPy from Stanford. Here, you don't even write the prompt. You define the goal and a metric for success, and an optimizer algorithm automatically generates and refines the best possible instructions to achieve that goal. Just let that sink in for a second. The human is no longer the writer. The human is the architect of the system that writes. Prompts are no longer just text. They're optimized parameters, just like code. And this leaves us with a final, really fascinating question to think about. The field is moving from prompt engineering to AI orchestration. And as these AI systems become more and more autonomous, as they begin to write their own instructions, our role completely changes. It becomes less about crafting the perfect sentence and much more about designing the goals, the rules, and the systems that these powerful tools operate within. So what does it truly mean to be an orchestrator in a world like that?